We're going to mount the motor to the motor mount and the prop to the motor. And the motor I'm using is a Turnigy 1500 kV motor. It's a Turnigy 2730 brushless motor. It's a park flyer size, and the thrust is about up to 410 grams using a 7 by 3.5 propeller or smaller. Because I don't want a tall propeller, I've gone to a 3-bladed propeller, and I've done extensive testing on a number of propellers for this particular motor, including 4-blade and up to 6-blade propellers. And the one that produced the lowest current drain and the longest run time, as well as the best thrust, or equal to the best thrust of even the 6-blade propeller, is this Gemfan 5045 bullnose propeller, and it's a 3-blade. It comes in a package. It's of 4, and it's meant for or 2. It has a left-hand and a right-hand version, and it's meant for quadcopters and the like, which often have small propellers. And there's a left-hand and a right-hand version. We're going to use the regular right-hand version, and this version, when it's turning right, will produce thrust behind the blade. And you see there's a front and a back. Now, because the motor is going to mount in the back of the plane, we're actually going to put the front of the propeller towards the motor instead of the other way around. And again, it should be producing thrust backwards when it's turning right hand. You remember we have this left hand thrust angle at the back of the plane, which will turn the plane to the right, compensating for the fact that the propeller is turning right and producing left-hand thrust, trying to turn the plane to the left. I'm also using a spinner system that's designed to fit onto the motor, and it's a 3mm to 5mm spinner system, and we put that on the shaft, and then the propeller forward facing towards the motor, and we'll tighten the nut down, and what that does is pull the rear part of the spinner towards the propeller, and it tightens on the shaft, gripping the shaft. And so you need to put a small rod through the hole in the spinner and turn it, holding the propeller, not the motor. Turn it down tight, and you'll see it grips the shaft firmly. Okay. This particular motor is an outrunner motor, so the outside has the magnets and the inside has the brushless coils. These produce more torque and can swing a bigger prop. That's why we've gone to a 3-blade, because this is only a 5-inch diameter prop, and we can swing more blades with the torque of this motor. Now, the motor itself has about a 1-inch mounting circumference, or 25mm mounting circumference, and that's what this motor mount is set up for. Instead of using wood screws to screw into the motor mount, I'm using through bolts or screws to mount it, because it's very difficult to get at an angle here and screw wood screws in, unless you take this motor apart and then screw the base in first and then attach this. But instead of taking it apart, I'm just going to use bolts. So I'm going to put my first bolt through, and you can reverse that if you like, but again, it's easier to get the screwdriver in the back. So we'll start one. And you notice also I have my outputs, my 3-wire outputs towards the bottom. Okay, they're actually going to go forward and connect up to the wiring in the forward part of the motor mount. But we're putting it down close to the vertical, which creates some drag and airflow so that we don't have two spots with additional airflow turbulence, just the one along here, along this vertical. So we're going to put the screws through and put the washers on, and these are small lock washers for 2mm, and then we have a 2mm nut that we're going to put on and start finger tight, and then the second screw through, the washer and the nut, and the third. It's going to be helpful to use a Phillips screwdriver to get this through. We'll loosen up the other screws a little so we have some maneuvering room. Okay. The spacing on this seems to be 25mm, and the motor seems to be more like an inch, and so the screws would go in at a little bit of an angle, but they work fine. Okay, and then the last one. And the washer, and the nut, we'll hand tight all those down, and then we'll finish tightening them with the screwdriver. And our motor mount's complete. These wires are going to go forward and go through the wing and attach to the ESC through the forward part of the wing. So if we like, we can take a tie wrap and put around the wires and the vertical part of the motor mount and pull that to hold them in place. There, we're just holding them in place so that the wires don't move around, because these wires can break off from the motor, and then you have a motor failure or even a short. So we'll clip off that excess from the tie wrap, and our motor mount is now ready to go.